Hi everyone, this is your struggling CS student here, and today let's solve another LeetCode problem. Let's take a look at today's problem. 3394. Check if grid can be cut into sections. Okay, this is a 1900 problem, so it's going to be challenging. So let's see. So you're given an integer and representing dimensions of an n times n grid with the origin at the bottom left corner of the grid. You're also given a 2D array of coordinates rectangles. Okay, where rectangles of I is in the form of start x, start y, and x and y representing a rectangle on the grid. Now each rectangle is defined as follows. Start x, start y represents the bottom left of the rectangle, and nx and y represents the top right of the rectangle. Okay, note that the rectangles do overlap. The task is to determine if it's possible to make either two horizontal or two vertical cuts on the grid such that each of the three resulting sections form by the cuts contain at least one rectangle, and every rectangle belongs to exactly one section. Now return true if such cuts can be made, otherwise false. Okay. Let's take a look at some examples. So two vertical cuts or two horizontal cuts. And we want to make it such that each of the three resulting sections contain at least one rectangle each, and every rectangle belongs to exactly one section. Okay. It's kind of like the problem yesterday, I guess. Not entirely sure, where like you have to ensure that you don't have like overlaps and stuff. I could be entirely wrong. Just a guess. Um, okay, let's see. This is the bottom left. So 1 0 and 5 2. When do we want to make a cut? Ideally, we want to make a cut such that it doesn't split a rectangle into, like it doesn't cut across one of the rectangles, right? Because then if let's say we cut across one of the rectangles here, suppose we do a horizontal cut like this, right? On y equals to 1, then the yellow rectangle will belong into two sections. It will belong into cut 1 and cut 2. It, let's see, uh, your task is to determine if it's possible to make either two horizontal cuts or two vertical cuts. But can we do one and the other? So can we do one horizontal and one vertical cut? Um, we cannot make two, or hence the output is false. Let's try to draw these out. I think we can't, as in we can't make one or the other. We have to make either two horizontal or two vertical. Uh, yeah. Let's see the example that they give us. N is equals to 4. Okay. So you have this. It's like this. So yeah, I'm just trying to go through an example right now. I'm not sure like what is the right way to solve these kind of questions. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay, so 0, 2, that's bottom left, right? bottom left and top right. Okay, so 0, 2, 0, 2, and 2, 4. Maybe I should 0, this is 1, 2, 3, 4. 1, 2, 3, 4. You have 2, 0, 2, and then you have 2, 4, 2, 4. So like this. So we got a rectangle here. Can I make the fill? Oh, I can. Oh, I can't. Oh, this? Oh, okay. Then you have 1, 0, and 3, 2. 1, 0, 1, 0. Wait, what? Okay, 1, 0, and 3, 2. Like this. 1, 0, and 3, 2. Then you have 2, 2, and 3, 4. 2, 2, and 3, 4. 2, 2, and 3, 4. Is it like this? 2, 2, and 3, 4. Okay, so it's like kind of really overlapping. And then you have 3, 0, and 4, 2. 3, 0, and 4, 2. 4, 2, like this. Okay, okay. I think we can play around with these test case, right? Oh shit. We can't make any cuts such that you can cut like this. Can you cut like this? Okay, I'm pretty sure you can only make one cut. As in, you can only make 2 horizontal or 2 vertical cuts. You can't make 1 horizontal and 1 vertical. Otherwise, this would look like a valid solution. And I wonder if let's see. Is there a case where it's overlapping but it's still valid? You could imagine a case where, if let's say we put one here, so let's make this another color. Like, I say this is purple, right? Let me remove this. Let me put this here. Move this, move this, move this. Okay. So, in that case, we can probably cut it like this if we add another rectangle here. So let's see if that is actually the case. So basically, we can overlap here. Yeah. Oh shit. Let me reset test cases. Let me add one more. Let's say this is 5 and 6. Okay. This is 6. And then we add another coordinate where it is 3, 4. 3, 4 to 4, 6. 4, 6. But this should be true, right? Yeah, okay. Okay. So kind of getting a better idea of the problem. So technically, it's okay to have overlapping rectangles as long as you can still slice them such that you fulfill the two criteria here. 3 resulting sections contain at least 1 rectangle each, and every rectangle belongs to exactly 1 section. Okay, so basically you can't cut it such that it's like this. You also have to ensure that every rectangle gets at least 1 section. I'm thinking like a greedy kind of way. A greedy kind of way. Probably line sweep, right? Yeah, I'm thinking line sweep actually. I'm thinking line sweep, but on a matrix. But so basically, we will try something like, can we cut a section here? Can we cut the section here? Something like that. And if they're overlapping, what does it mean if they're overlapping? Do we just merge them? Like as one triangle, one rectangle? I think we do actually if they're overlapping. Because it doesn't really matter if it's like this or if it's like this, right? Yeah, I think it doesn't really matter. So it's just a 2D line sweep, and then you check whether you can fulfill the criteria. But where do we do it on? We do it on the ends, right? So let's say we process from left to right. We will check something like, if we cut this section here, how many do we have left to the right? If we have at least 2, then we can continue, right? In this case, we only have 1, so we can't. So we can't make 2 vertical cuts. But here, we'll do, let's say, from the bottom up. Then we will say at the end, we can make a cut here. At the end, we can make a cut here. So as long as, okay, when can't we make a cut? We can't make a cut if it's like something like this, right? If it's something like this, that means the next cut that we can make is something like that. So let me put another case where it's 3 3 instead of 3 4, and then it is 4 5, I guess. Say 4 5. Is it 4 5? Maybe still 4 6. The top right, I move it down 1. So now this is 3. No, this is 3. This is 4. This is 4 5. Okay, this is 4 5. 5. This will be false. Oh, rectangles are overlapping. Wait a second. We have 3 3 to 4, and let's do 4 6 then. 0 2. Wait, 0 2. Oh, 0 2 to 2 4. Oh, we don't even have overlapping rectangles, is it? Oh, no 2 rectangles overlap. I see. Okay, then. Okay. Then it makes the problem a little bit easier. We don't really have to merge it. Oh, then did I made a mistake here? Probably. 0 2 to. Oh, it's like this. Oh, I see. So this is my problem. Oops. It's like this. And it's like this. Okay. Sure, it's fine. That's fine. 0 2 to 2 4. Then this is 1 0. 1 0 to 3 2. 2 2 to 3 4. Then you have 3 0. 3 0. 4 2. And then you have 3 4. 3 4 to 4 6. So it's originally like this. Let's add in a couple more units. So this is 5, and then this is 6, right? This is 6. I'm going to copy this whole thing again, put it here, but this time around we want it such that it's like this. So this is 3 3 and 4 5. No, 3 3. It's not overlapping, is it? It is overlapping. 3 4. 3 4 and 4 6. What if it's like this? Is it still? Oh, it's still overlapping. 3 3, starting at 3 3. Oh, it's 3 4. Wait, no, what the hell? Yeah, isn't it? Why can't I start 3 3? 0. This is what? This is 2, 2, 2, 3, 4. 2, 2 to 3, 4. Start X, start Y is the bottom left corner. 3, 4. Can it be like this? Wait, am I missing something? 3, 4. 3, 3, and this is 3, 5. They're not overlapping, is it? Oh my god, this is 2, 2, and 3, 4, right? 2, 2, 3, 4, and 1, 0, 3, 2, 0, 2, 2, 4, 3, 0, to 4, 2. Then you have 3, 2. Oh my god, this is 2, 2. Okay, fine. This is 2, 2 to 3, 4. Okay. I see 2, 2 to 3, 4. And then this is 3, 4 to 4, 6. Now this is 4, 5 this time. So this should be false. Rectangles are still overlapping. Oh my days. Why is that? 3. It should be 3, 3. 3, 3 to 4, 5. Start X, start Y. That's 2, 2, 2, 2, 2, 4, 4. Oh my days. Is 3, 4. Is also 3, 4. Okay. It's still overlapping. 2, 2 to 3, 4. 3, 3 to 4, 5. And then 3, 0. 3, 0. That's 3, 0. 3, 0. To 4, 2. Okay. 2, 2 to 3, 4. 2, 2, 3, 4, 2, 2, 3, 4. That's 2, 2, 2, 3, 4s. Okay. So this is true, and this is false. Yeah, like what we expected. 1, 2, 3, 4, 5. Okay. Okay. So how will we do this? Basically, we can treat this as like one large block, right? Basically, we treat this whole thing as one large block. Also, we do have to match if their heights overlap each other. So we have to check on the x-axis and the y-axis. If somehow okay, this is for the vertical cuts. How about the horizontal cuts? How do we check for horizontal cuts? Let's make another copy. A horizontal cut, when they overlap, right? When they are, how should I put it? This is their start y. Yeah, their start y and their ny overlaps. And if their start x and nx overlap, so probably like something like this. Okay, for the sake of simplicity, let's make it something like this instead. So if they are start x, you have a start x here, you have a start x here, then you have another nx here and an nx here. So if they overlap, then basically you want to treat them as the same, right? Likewise here, you want to treat them as the same. So in that case, we just merge it. We just merge it, and then we check if we have 3 non-overlapping sections by the end. I think we can go with that. So it's definitely line sweep. It's definitely line sweep, and still a little bit hard, I guess. Okay, so but now we generally get the idea of how we want to solve this problem, but how do we, like, now is the implementation problem, right? So definitely do line sweep. I guess we're going to start with the x first, then we do the y. start with we also have to sort it. So we only care about starting x's and starting y's. Then we just need to do two line sweeps. Maybe do uh, x x array, I guess, and get y array, something like this, for x1, y1, or should I call start x, start y. Then we have and x and y in rectangles. Then we only care about the x's. Start append, well, what the one append. The x value, this is the bottom left. So the bottom left will be start x, start y, start x, start y, right? But then we also want to append how do we calculate that? That would be the starting x, and then, okay, starting x, no, this is not starting x, this is the nx, this is the nx with the starting y. Yes. Okay, let me make it such that it's not so confusing for myself. Let me erase this, erase this, erase this, erase this. I'm gonna call this start x, start y. This is nx, this is ny. This means this is start x, right? And no. This is nx, but start y. Likewise here, I think that's it, right? So we're going left to right, so we care about this. Later when we go bottom up, we probably just care about these values. Then we go from left to right, we care about these values. Do we need this one? I don't think we need, right? Okay, but what if we need? What would this be? This would be the starting x and the ending y. I don't think we need this, but I can just leave it here for now. Yeah. Okay, so this is the starting point. This is the ending point. And now later when we go up, we do y array dot append nx start y with nx and y. Nx and y. Okay. Now we just need to merge them. Right? We just need to merge them. Maybe we do something, we can define like a function here. Merge intervals, I think. So that will take in like an array, and then we need to return the merge array, something like that. And afterwards, you can say something like, so we do merge intervals of x array. So that will be something like merged x, and we do merged y is equals to merge intervals of y array, then return length of merged x is greater than equals to 3, or the length of merged y is greater than equals to 3. So this would mean that we could actually make three vertical cuts along the y-axis. This means we can make merge x means we can make three vertical cuts along the x-axis, and for merge y, if the length of it is greater than or equals to 3, that means we can make two horizontal cuts. Okay, so now we just need to solve the sub-problem of merging the intervals. In that case, merge would be equals to, let's say, the empty array. Oh, we need to sort it as well. So afterwards, x array dot sort, then y array dot sort. Then for starting and end in array, right? If merged and merge of -1 is something, we would merge dot append something else, which is this is if there's some sort of conflict. Else, if there's no conflict, then we just do the easy case, which is merge dot append starting and the end. Okay, now here it could be the case where, could be the case that the end, so the last array, the last element star, it's if it's like this, it's non-overlapping. If it's like this, it is overlapping. That means we want it such that the star is less than merge of -1 of 1 strictly, right? Because if it's like this, if they are exactly equal, we can make a cut. Yeah, that is the case. Then we want to append. No, we don't need to append. We just need to modify. We need to modify is equals to the max of this and the end, right? And the end. So it could be the case that it's like this. Then in that case, this wouldn't exist. If it's like this, then we want to take the max of this endpoint versus this endpoint. So it's really that it. Tuple does not support. I don't. Okay, then we will do these indices instead. Oh, what happened there? Okay. Am I still returning always true? So it's failing to detect the failure case. Let me see the merge x and merge y. Frame, merge x, and merge y. For the failure case, let's take a look at this. If less than or equals 0, 2, and 2, 2. 0, 2, 0, 0, 2. We'll print the x array and the y array. What happened? X array, y array. Okay, the first I should expect to see it's 1. Hey, what is this? This is 1, 0, right? 0, 2. Uh-oh. 0, 2, 0, 2. How am I getting 0, 2 there? 0, x is 0. Oh, this one. Okay, this one. Okay, sure. So 0, 2 is first. Okay, fine. Then you have 1, 0. 1, 0, which is here. Then you have 2, 2, which is this one. Then you have another 2, 2. Another 2, 2. Let's take a look at this example. So you have 0, 2 to 2, 4. Then you have 1, 0 to 3, 2. Then you have 2, 2 here. Right, 2, 2 to what is it? 2, 2 to 3, 4, right? Yeah, then you have 3, 0. 3, 0. Or this one. 3, 0. to 4, 2, and then you have 3, 3, 3, 3 to 4, 5, 3, 3 to 4, 5. Yep, yep. Okay. It should be such that if we go from left to right, then this, and this, then you have this again, and this, and this. Bam, okay. The merge x, 0x, 0, 2, and 2, 2, 0, 2, 0, 2, and 2, 2. Wait, there's something wrong with my implementation for sure. Oh man. Maybe I just take a look at the y-axis then. Take a look at the y-axis. 2, 2, starting from x is 2, and y is 2. Really? Why is it like this? 2, 2, 2, 2. What's starting here? This should be the least. Oh, I think it's because of my sorting. For my y, then key is equals to lambda. X will return. We want to sort by the y-axis, then the x-axis. This one is lambda x. We want to sort by the x-axis, then the y-axis. Doesn't really matter, I think, in this case. This is one way. Okay, just take a look. Now y-axis is 3, 0 here, correct? Treat 0 first. Then afterwards it's 4, 0, 4, 0, which is here. They start on the same level. We have 3, 0. It is kind of wrong, isn't it? Basically, I don't think we want to append two values. We just need to append one, yeah, which is the starting x and the ending x here. Okay, then here, when we append y, y is the ending x, and the ending y, like this. Starting x to the ending x. This is from the, no, starting y to ending y. What am I talking? Oh my god. Okay, it looks good. It looks okay, wait. Starting y, ending y, starting x, ending x. Then I think my sort doesn't have to do anything else anymore. Yeah, okay. Okay, this kind of looks good. Line switch merge intervals, but 2D. And what's the time complexity here? Time complexity is, did we ever actually make use of the n? No, right? Yeah, the n is kind of like just to throw us off. I don't know, maybe to give us like an infinitely large 2D grid. But the sorting is definitely rectangles dot length n log n. Yeah, if let's say there are n rectangles, then we will have n starting and ending points. Sorry, if there are n rectangles, then we will have n starting and ending points here. Then that will be basically n log n because of the sort. For the merge intervals here, it takes linear time. There will be 2n here. Then afterwards, the space complexity, because Python uses team sort, it will be O(n). But also, since here we create a new merge array based on the x and y axis, that here the time complexity is also O(n). So overall, the space complexity is also O(n). and overall time complexity is n log n, and the space complexity is O n. I think that should be it unless I make some critical mistakes. Yeah, I'm just gonna submit it. Hopefully I didn't make any mistakes, and I did not. I'm very, very happy that I managed to solve this on my own. Line strip 2D, I guess I kind of relate to yesterday's problem, but yeah. Let's take a look at okay, yeah, this line sweep. It's more like an interval problem than a line sweep, I would say. So um, let's see. Yeah, kind of like the same idea. Also, we have to sort, yeah. What is this dim? Oh, dimensions, okay. Check cuts, dimension. Just pass in a 0 and a 1. Then they just sort the rectangle. 0, 0, which is the starting x. Oh, I see. Okay, okay. Right. That makes sense. Because at the end of the day, you're just storing by the starting x and the starting y. Okay, fair enough. So we sort it, track the first coordinate. Sure. So in a, wait, what? What is this talking about? In-place algorithms. Oh, okay. Oh, are they modifying the? Oh, they are modifying it because they're sorting it here. Whereas here, we preserve the original input, but we take up additional space because we're using new data structures to store the values of interest. Mm, yeah, okay. So n log n and OS. Oh, okay. Sure. Python, yeah, team sort, combination of merge and insertion sort, complexity of ON. Hmm. Okay, I'm not sure if it was easy, but yeah, at least it was challenging for me. Anyways, this is the code for today's problem. Thank you for watching and happy grinding.